So this is a question about the translational motion of center of mass. So the main idea of this whole section is that if there is no external force onto an object, then the center of mass will have no acceleration. And that is the idea that we apply in this question. So in this question, we have a balloon and we have a passenger. This whole system is initially at rest, but then this passenger starts to slide down the rope. And the question wants us to find the direction of the balloon. We want to know how it moves, what's the velocity, and we want to know what happens if this passenger suddenly stops. So as I mentioned before, since there's no external force, the center of mass of this whole system should remain stationary. So the velocity of center of mass is 0. And since center of mass is equal to the mass of the balloon, which is big M, times mass of the balloon plus mass of the person, passenger, which is small m, times mass, the distance of the passenger over big M plus small m. So if we take the derivative of both sides, we have VCM equals m times VB plus small m times VP over big M plus small m. And since this is 0, we have m times VB plus small m times VP equals 0. So this is what we're trying to find. This is the equation we'll be using. So let's say the velocity of this passenger with respect to the balloon is negative v. Is passenger with respect to the balloon. It's negative because it's going downward. And if then we know that the velocity of the passenger with respect to the ground is the velocity of the balloon minus its relative velocity. So we plug that in and we have small m times VB minus V plus big M times VB equals 0. And that gives us VB equals small m over big M plus small m times V. So this is the equation we want. And what it's saying is that the velocity of the balloon is proportional to the velocity of the passenger relative to the balloon. So in the passenger's own coordinate system, the faster he's sliding down, the faster the balloon will be moving up when we are viewing it from the ground. And this is going up because the passenger is going down and the center of mass has to stay stationary. And again, if the passenger stops, that is if V becomes 0, then VB will also become 0. If he stops, the balloon will also stop.